Good evening, ladies and gentlemen. You're very welcome to the lecture this evening. I'm really here under false pretences. My name's Richard Clark. I'm the Church of Ireland Archbishop of Armagh, but I am actually representing Alan Abernethy, the Bishop of Connor, whom, as many of you will probably know, is off duty at the moment as he's ill. So I'm here, as I say, as first sub. Well, I think it's first sub. I'm not quite sure. I've no idea how many other people Barry may have asked before he asked me to take on this role. But it's certainly a great pleasure to be here. First of all, I would want to thank the office of the Vice-Chancellor, and the Pro-Vice-Chancellor is here representing the Vice-Chancellor's office. He will shortly be introducing our visiting lecturer. I'm told by Barry, to thank the Church of Ireland's Board of Education Northern Ireland for the sponsorship of this, and this gives me particular pleasure as I'm actually the chairman of that particular body. But I certainly do so with great gratitude. As you'll probably know, the lectures, these Queen's University chaplaincy lectures, have been in constant flow since I think it's 1957. And over the years, many different people have performed, so to speak. There have been academics from different disciplines, theologians, even an occasional bishop or archbishop. And I think I did this about 3 or 4 years ago, in fact, but it was only a quarter of the whole lecture on that particular occasion. But even if I wasn't here, as I say, to represent the Bishop of Connor, I can truthfully say it would give me huge pleasure to be here. This particular area of where science and religious faith may meet is, I think, one that all of us are going to have to face more and more as we head into the future. As we know, we are now plunged into what's sometimes called the Fourth Industrial Revolution, where robotics of immense sophistication, the huge amount of connectivity that is now possible wirelessly, and of course, in addition to which, we have just simply the massive power of computers. I don't like the term artificial intelligence, but we certainly have self-learning computers, and all of that is going to mean that very soon we will have to ask the question, what is it to be a human being? Because we won't have much use in secular terms. We will be pretty useless in secular terms and valueless in secular terms, because most of what we attach our identity to as being of value will be done for us. And so we're going to have to find a future where, yes, there is an ethic. And what are we going to base that ethic on, that self-understanding of humanity? But I think there's a further issue. As I've got older, maybe it's impending doom or something that makes me think of it, but I find myself more and more looking at the psyche of the human person, and how there's one part of our psyche that is so concerned with structures, with how things work as they do, with why things work as they do. And then that other part of our psyche where we find ourselves asking the questions, well, is there any significance to this? Is there any meaning to this beyond itself? Is there any meaning to human relationships? What is our relationship with that which is other, that which is beyond us? Or is there anything beyond us of significance? And so those two parts of our psyche, those two parts of our brain, if you like, very often have to meet somewhere. And I think that possibly astronomy can be the place in which they meet most readily. Because yes, on the one hand, we're concerned with science. Why are things working the way they are? Is there a structure? Can it all be explained in formulae? Or as Pythagoras said, does it come down to everything being number of one kind or another? And then there's the other side that looks to the sky, listens to the work of astronomers, and says, no, there's something here that is wonderful. There's something here beyond comprehension. There's something here that is awesome. And so very often we find those two worlds, those two bits of our psyche, being drawn towards one another. And that's why a lecture such as tonight, which not only talks about faith and science, but relates the whole area of astronomy to human understanding, is one that I think is surely of value for all of us. So I'm very, very grateful that this lecture has been put on, and for that I do thank Barry. I think it's hugely useful at this time that we should consider such matters. But now I'm going to hand over to Professor Jones, who I think will formally introduce our visiting lecturer. Thank you very much indeed.
Thank you very much, Reverend Clark. That's a wonderful introduction and very thought-provoking in itself. Thank you. Ladies and gentlemen, I want to, on behalf of Queen's University, warmly welcome you to the Church of Ireland's annual Theological Lectures for this year. It's always a wonderful event, and over many, many years, Queen's has brought many great thinkers to our halls here. And many of those have been associated with the Church of Ireland lecture series. So I know we're in for a treat tonight. No pressure, okay? And I know that the theme will be very interesting, as you'll see as you followed on from Reverend Clark's introduction. So we're always very proud to support the lectures. Religion is a very, very hot and a global topic today. It's one for the same reasons that Reverend Clark mentioned. So many things are either assigned to religion or we talk around them. We have more free discussions about them. And it's venues like this that allow us to do that. In Queen's, we have our Religious Studies Forum, and it's wonderful the work that's been done, led by Professor Livingstone, and some of the questions and some of the thoughts that have been put together. We bring together theology in the disciplines, and we've heard wonderful treatises of the overlap between theology, anthropology, politics, science, neuroscience, sociology, and you realise what an integral part these discussions are in our society. These have been very, very successful, and I really hope that they go on much, much longer. Now, at this stage, I have a plug to actually put forward. I hope you will see one of these as you go out. Okay, and many of you may recognise, albeit probably from about the second row back here, the wonderful face of Baroness Nora O'Neill. And we have another one of the lectures in this series is the McCosh Lecture, which is on Friday the 10th of May at 2 o'clock in the Great Hall, organised by the Religious Study Forum, and will be delivered, as I mentioned, by Baroness O'Neill, the Emeritus Professor of Philosophy at the University of Cambridge and also former President of the FBA. And she has been in this very lecture theatre, and I must admit the sound system did work a bit better then, and to have debates, and they have been most wonderfully received. So religion has had and continues to have then a major influence in our society. And it is regarded as an area where research is needed, and research at the interfaces is needed. Now this brings us to today's lecture. And what a treat we really, really have in store for us here. So, the title being Science, Religion and the Search for Extra-Terrestrial Intelligence, or SETI, as you've referred to it as. And it's going to be delivered by the Reverend Professor David Wilkinson. It is a real pleasure to invite you here tonight. I hope you will be with us many more times. And as everybody is here, it's a packed hall. We're looking forward to hearing more from you. So Professor Wilkinson is Principal of St John College in Durham and is a renowned writer, broadcaster and theologian. Now, you're a man of two parts here. You started off as a scientist. Those things never leave you, but as you'll see in your work. And you, as a physicist, and you also have a PhD in astrophysics, looking at the process of star and galaxy formation and mass extinctions, looking to the skies, as the Reverend Clark mentioned. After this, then, you studied theology at Cambridge and became a Methodist minister. You completed a PhD in theology, and since then you've held a number of positions at Durham University in apologetics and theology. And as I mentioned, you're the principal of St John's College and lecturer in the Department of Theology and Religion. Anybody who's read the works, you'll see that a lot of the popular culture comes through, and I think that's a very interesting theme. And you've written on areas such as the X-Files, Star Wars, to Christianity, and those relationships, as well as many other popular books. You'll see up there on the bottom right, you'll see one of the most recent titles, which is Science, Religion and SETI. You'll also see When I Pray, What Does God Do? And Christian Eschatology and the Physical Universe, all key areas that Professor Wilkinson has written on. Professor Wilkinson is a canon at St Albans Cathedral and ecumenical fellow at Liverpool Cathedral, and is a frequent contributor to Thought for the Day on BBC Radio 4, which I know I've heard your voice before on that. So the discovery of exoplanets alongside new missions to the surface of Mars, or back to Moon again as we heard last week, has given fresh interest and excitement in the search for extraterrestrial intelligence. So in today's lecture we're going to hear more about that. We're going to hear more about the science of the quest and how it relates to Christian faith, such as the doctrines of creation, the images of God and redemption. And the thesis being proposed is, rather than science and theology being in conflict, it's argued that Christian theology promoted belief in other worlds and can be a fruitful dialogue partner today. It's a very interesting area to be talking on. So really, without any further ado, may I warmly welcome you in the usual way to give your presentation. Thank you very much.
Archbishop and Pro Vice-Chancellor, thank you very much for the warm welcome, and indeed, in a sense, what you've both said already, I'm not sure I've got very much more to add. This will be a commentary on the shorter form of what we've heard. It's a delight to be here. Thank you for the invitation and to be part of such a distinguished series of lectures. It's a real privilege to be amongst you. I'm sorry to take us from the high point down to Piers Morgan and Good Morning Britain. But I found myself watching morning television not so long ago and found a bizarre situation. The main subject was Love Island. A quality television programme in its own right. But as this was going on, two other things were going on. There was a conversation on Twitter, which was being relayed to the studio, about whether God started the Big Bang. This was causing quite a lot of activity on Twitter. Meanwhile, in the studio, Sean Ryder of the band Happy Mondays, that some of you will recognise, and a young scientist were debating UFOs. This was all going on at the same time, and I found myself thinking, well, this is interesting. Why isn't there a theologian involved in this? Well, maybe not to comment on Love Island, but certainly to comment on God and the Big Bang and perhaps the existence of extraterrestrial intelligence. It showed me, I think, a little bit of the fascination with some of these big questions within not just the academy, but also within popular culture. It also showed me a kind of cultural phenomenon of whether religion had any important voice in these kind of conversations. To give you another example, if the sound is working now, are we all okay with that? Some of you will know a series called The Big Bang Theory, one of the worldwide most popular comedies at the moment. And the spin-off series to The Big Bang Theory is a series called Young Sheldon, which traces the childhood of phenomenal physicist Sheldon Cooper as he grows up in six-day creationist Texas. You can imagine some of the tensions that are going on in this series. And within Young Sheldon, there's a particular relationship which develops between this small, brilliant young mind and the local pastor of the church, Pastor Jeff. This becomes an ongoing joke in the series. This, I hope, you'll be able to hear, is a clip from Young Sheldon. The cleric going, I want to oppose such a view this evening, although you might find in the question time that I might have the same reaction. But I want to oppose the view this evening that Christianity has not engaged fruitfully in this question of a life elsewhere in the universe. And so my plan is to say a little bit about speculation on many worlds and the role of Christianity, then to move to what's already been mentioned, and that is the scientific work in exoplanets, which has brought this subject really to vast interest, and then talk a little bit about challenges to and contributions from the Christian faith. I do so with a degree of hesitation. It's said that Giordano Bruno was put to death at the stake for speculation on other worlds in 1600, and Thomas Paine in The Age of Reason, commenting on the existence of other worlds and people who believed in Christianity, claimed that the person who thinks he believes in both Christianity and other worlds has thought but little of either. So I throw myself upon your mercy this evening, hopefully not death at the stake, but we'll see. So first of all, let's talk about the history of this. And from the Greeks, we have a fascination of many worlds. And what's interesting in some of the church fathers is exactly that same fascination. You see it in Origen, as Origen speculates about other worlds and other intelligent life. In Ambrose and Basil, you get it. It's slightly more reserved, but it's still there. And as Christian thought goes on, this interest in other worlds is fruitful in some areas, but is opposed in others. Thomas Aquinas appears on the scene, and you remember Aquinas baptizes Aristotle, or the Aristotelian universe. The earth becomes the centre of everything. And that acts as a handbrake to some of the speculation on other worlds. I think sometimes Aquinas is overly criticised for this, because remember, Aquinas' view of the Creator had within it this sense of extravagance that God creates with. But nevertheless, the domination of the Aristotelian universe led to some reserve about speculation in other worlds. In 1217, the Archbishop of Paris asked Etienne Tempier to have a look at some of the problems that Aristotle was giving the church, and he came out with over 200 of them, including a sense of this inhibited God's freedom to create. There's an important sense, because some of the speculation about other worlds was driven by this sense that if God was free, he couldn't be limited by our presuppositions of what he should or shouldn't create. In fact, of course, this was a contribution to the scientific revolution itself. Because God was free to create, you had to look at the universe to see what was going on. And you could be surprised by the universe and surprised by what God had done. Another key theological move happened with Nicholas of Cusa. And Nicholas talked about how the special nature of human beings was not about where we were in the universe. It was about relationship. Now, this was a key move. It meant that you could think about other life without sabotaging that sense that human beings were special. We were special because of the gift of relationship, of intimate relationship that God had given to us in creation and confirmed in the incarnation and indeed the death of Jesus for each one of us. That was the sense in which human beings were special, rather than us being alone in the universe or at the centre of everything. And this led again to a fruitful period of interest in other worlds. Christian Huygens and Richard Bentley, as they began to build telescopes that showed us just how big the universe was, they didn't see this picture. This animation is from the Hubble Space Telescope as it looks at its own deep field, as it's called, some 13 billion light years or so away from us. But they did see the size of the universe. And the size of the universe led them to speculate again about other worlds. They used an argument which went something like this. They said, Psalm 19 verse 1 says the heavens declare the glory of God. So they said, we look at the universe and there are parts of the universe that we'll never see. Oh, they said, maybe there must be other intelligent life which will see the glory of God in places that human beings will never see. Now, I don't commend the coherence of that theological argument to you, but it's interesting that that's what was driving them. So, to sum up this introduction, if you like, what was happening was that there was a tension going on. And I've decided to put the tension against Huygens' beautiful telescope, two mirrors held together with a piece of string. Such was the difficulty of astronomy in those days, but never mind. Those against were saying Aristotle is dominant. That to talk about other life would undercut human status. How do we deal with original sin? Would that be passed to other worlds? And what about salvation? However, those speculating about other worlds had a number of arguments to oppose this. God was free to create, we've seen. That God was a God of extravagance in creation. Third, that the key to human status was about relationship rather than place. That the laws were universal because this was one God, and therefore the laws that made possible life in one part of the universe may be possible elsewhere. And the importance of observation. That in order to really think about this question, you shouldn't do it primarily theologically. You need to observe the universe. Now, keep those themes in your mind, if I may suggest that, because we're going to come back to some of these theological themes in a moment. But I'm going to pick up on observation, and I'm going to go quickly now to the kind of observation that has really transformed the area. And that is, roughly, we've now discovered that there are around about 4,000 planets outside our own solar system. In 1995-96, we were unsure. We knew that there were planets in our own solar system. We suspected there would be planets because of the way that we thought planets formed, but we weren't too sure. Now we know some 4,000, and some of them are really quite close. There's an Earth-like planet in one of our neighbour systems, Alpha Centauri, only a distance of 4 light years away. We also know that there's a planet around Barnard's star, some 6 light years away. And just a week and a half ago, a man came into my office in Durham called Pete Warden, who works for the Breakthrough Initiative. And out of his pocket, he took a spaceship. I mean, a real spaceship out of his pocket. It was a little piece of metal, smaller than the size of a postage stamp, with camera and antenna and all the rest of it on the piece of metal. And that piece of metal, in maybe a year or 2 years' time, if there's enough money, will be blasted at the end of a laser beam to Alpha Centauri. About a tenth, fifth of the speed of light. It'll take about 20 years to get there. By the time it gets there, it'll then broadcast signals back, so another 4 years to get back. In 25 years, 26 years, we might see the planet around Alpha Centauri. I might still be alive at that stage. Extraordinary kind of ability that potentially that we might have. And this is how many planets roughly we've got. I say roughly because I only checked it at lunchtime today. It may have changed since then. 3,926 confirmed planets in 2,927 planetary systems, with over 600 multiple planet systems. That is, we've seen planetary systems where there's more than one planet. We've also seen planetary systems where there's more than one star. So those of you who are Star Wars fans, Star Wars is right, that there are planets where you can see 2 suns from time to time. And this shows, this is a very simple plot of the planets that have been discovered by year of their first publication. And the yellow line there is the mass of Jupiter. We saw big planets first. As the technology got better, so we were able to see smaller planets. The technology by which we've seen planets is fascinating in itself. I mean, it is so, to use a scientific word, cool. Because the difficulty is you see a planet close up to a star, if you're there. But the further you go away from that star, the more difficult it is to see the planet, because the glare of the star masks the planet itself. So how do you locate planets? Well, one possibility is that as a planet rotates around a star, gravity, of course, keeps the planet in its orbit. But gravity also works from the planet to the star. So the star, as the planet orbits, wobbles just a little bit. Not very much, just a little bit. So can you see the wobble of the star? Well, it's very difficult to pick up until you realise that, of course, light is affected by the Doppler effect. And the Doppler effect means that the wavelength of the light, as you see it, is affected by an object's motion towards you and away from you. And so you can look for the little wobble in the star by looking to see whether its light is red-shifted or blue-shifted. Rather like this little animation. You see the planet going around the star wobbling just a little bit, and you see the movement of the spectral lines towards the blue end of the spectrum and then towards the red end of the spectrum. That is such a neat way of looking at planets. And that was the first method that we used to see planets and still continues to be fruitful. Method 2 is that sometimes you might see a planet move across the surface of a star. And the light curve, the brightness, dips just a little bit as it moves across. And you might say, well, you've got to be very lucky to see such a situation where a planet moves in front of its host star. Well, of course, the universe is a very big place, which increases the odds that we might see this. And the Kepler spacecraft in particular was able to look at a patch of sky, here it is, and was very fruitful. These are some of the planets that Kepler was able to identify just in that patch of sky. Then lost its sense of direction. It started to go all over the place. Very intelligent engineers were able to use the motion to see even more of the sky. But that was the second method. The third method is even cooler than the first two, even if that's a word. And that is that Albert Einstein, you remember, said that space and time is rather like a stretchy fabric. And when mass is in the midst of that space and time, the space and time is warped or changed. And light follows the path of that space and time, or to put it bluntly, light is bent by gravitational mass. And so if you have a situation, as you see at the top left of the slide, where you have a background star which is emitting light, and a star comes in front of that star, the light from the distant star is lensed or focused back to you. The light curve increases, and you see that increase in light. And in fact, it happens with planets as well. So that as a planet moves in front of that background star, you get a little effect for a planet. And that's exoplanets discovered by gravitational microlensing. And this is now big business. So Kepler, unfortunately, is just about passed away and died. The current satellite TESS, a Transiting Exoplanet Survey satellite, has just started to discover new planets. We've been waiting for the James Webb Space Telescope for quite some time. That will be launched in a little while, and at that point we'll be able to see even more. And as I said, the current state of play is this, as I checked at lunchtime. 3,926 confirmed exoplanets. You notice that many of them are rather large gas giants, but 156 we would call terrestrial, Earth-like planets. So, So we know that there are Earth-like planets there. The next question is, are those Earth-like planets going to be stable long-term? And that depends on how big their host star is. And what we do know is that there's a number of these Earth-like planets around long-lived stars. Ours is a G star, and we've discovered a number of planets around similar types of stars. These stars will be stable over a long period of time, rather than exploding in supernovas or black holes. That's important. And then, not only do you have to have that, but you've also got to have the right temperature on the planet. What's called, the planet has to be in the habitable zone, where liquid water, we believe, should be there. And we've found that. So here we have the Earth's habitable zone shown by the green. You notice it's a bit fuzzy with Mars and Venus, but we've seen Kepler 452 have a very similar system, and Kepler 186. So we've got Earths, we've got stars that are about right, we've got habitable zones that are about right. We also need, of course, to think a little bit about the atmosphere, because we now know that Mars no longer has life. Did it have life in the past? Well, we need to drill below the permafrost to try and see if there's any relics of life in that, which we're beginning to do. As this probe on the surface has started to do, it'll be a few years yet, I think, before we drill deep enough to find that. And so you might say, well, that concludes the argument, doesn't it? After all, how many stars are there in the universe? Well, everyone knows there's 100 billion stars in the Milky Way galaxy, and that galaxy is one of 100 billion galaxies in the universe. I know it's late on is it Tuesday night? Yes. But it's a very easy calculation. How many stars are there in the universe? You multiply 100 billion by 100 billion. The answer is a lot. I mean, if you then say that probably the majority of those stars have planetary systems, well, maybe a fraction of those have Earth-like planets, a fraction of those Earths are in habitable zone with the right atmosphere. Well, you're still talking about billions. And people pause and say, well, obviously, there must be other intelligent life in the universe, mustn't there? Well, not quite. Or let's just say that it's an interesting argument, but let's qualify it in two ways. The first way is to say, if I may put it like this, it's a long way from an amoeba to an accountant. Well, yeah, it's a long way from an amoeba to an accountant. So even if you're able to form amino acids either in the early ages of the Earth or in comets or wherever, it's still a long journey towards intelligent and conscious life. And a journey that's very sensitive to the environment, a long-lived environment. And indeed, I'm afraid we don't know a great deal still about what is intelligence or consciousness, the next great revolution. But even so, it may be that the universe is full of simple life, but not intelligent life, and we need to make that distinction. And for those of you who are great Star Trek fans, I'm sorry, but Star Trek wouldn't be very interesting if it was to boldly go to seek out even more bacteria. So we could be facing a universe which is full of simple life. The second caution comes from Enrico Fermi in 1950. Fermi was a great mathematician, physicist. He and a number of his friends went to lunch one day. They were having some fun together as they talked about two stories that had been in the newspapers. One was the observation or claim of flying saucers. The second was the mysterious disappearance of trash cans in New York City. And in a famous cartoon in the New Yorker, these two were put together, these two news stories. And Fermi and his friends were talking about whether flying saucers were the best form of interstellar transport and all the rest of it. And Fermi went quiet. He had a habit of doing this occasionally as he thought about something and tried to work it out in his head. And during lunch, he looked up and he said, "Where is everybody?" Now, what he meant by that was if a civilization in the galaxy existed, they should be here. Because what Fermi had done was a very simple, well, for him, very complicated for us, a calculation. It goes something like this. Imagine here's our home star, and we begin to send out self-replicating robots. Those robots find another star, they replicate and send copies of themselves out. And you begin to see how they colonize the galaxy. And you think to yourself, with all of the crashes that would be built in and the fact that they end up at the same star and all the rest of it, you can calculate roughly how long this process would take to colonize every star in the Milky Way galaxy, 100 billion stars. And Fermi calculated, not too far away from what we think now, that this process would take about 300 million years. Now that sounds a long time, but in fact, compared to the age of the galaxy, it's very small, because the age of the galaxy is 10 billion years. So Fermi's point was, if they existed, they would be here, because they've had enough time to colonize the galaxy. That is, if life was being really easily made throughout the galaxy. If they existed, they would be here. Leo Szilard, a friend of Fermi's, a Hungarian physicist, replied to Fermi's, if they existed, they would be here, with the line, "They are here and they're called Hungarians." That was his response to it. But of course that takes us into the whole area of whether we're a visited planet or not. I haven't got time to go through this in detail, but of course it raises questions about hoaxes and conspiracy theories of alien abductions or alien... I read a survey the other day that said that it estimated that 4 million Americans had claimed to be abducted by aliens. I mean, I do find that hard to believe. I mean, what would aliens want with 4 million Americans? I mean, with respect. And so, I mean, some of the questions here about really, is there enough evidence? And you might want to ask some questions about that. I don't want to write this off in any way, but I do want to say that I'm not convinced that we've got the kind of evidence that would say we're a visited planet. So for me, the Fermi paradox, as it's called, if they existed, they would be here, is really quite strong. And for what it's worth, my own guess, stressing guess, is if I weigh the evidence, I'm afraid I'm pushed towards that we are alone as intelligent life in the galaxy. It's not to say there isn't other life in the galaxy, but we're alone as intelligent life. But there could be intelligent life in other galaxies. The Fermi paradox doesn't rule that out. But there is a problem with that. Imagine there's a civilization in Andromeda, one of our nearest galaxy neighbours, and they send a message saying, "Hello, is there anyone there?" That message takes about 2 million years to reach us. If we then send a message back and say, "Yes, we're here, who are you?" that's another 2 million years. That's not an interesting conversation at the end of the day. Now, to make the serious point on the basis of that, and that is there could be intelligent civilizations, but the problem of communication means that we might never know that they're there. They might be just simply too far away from us to know that we're there. However, after that brief canter through the contemporary science, can I come back to some of the theological questions now? Is that all right with everyone? And that is to say that some of the speculation about life elsewhere in the universe, particularly intelligent life in the universe, has been interpreted in different theological directions within our current thinking. First, Paul Davies argues that the discovery of life elsewhere in the universe would be evidence for cosmic design. Now, some of you will know that Professor Davies, over a number of years, has talked about the Goldilocks enigma, that the laws and circumstances of the universe seem to be just right for life to exist. And indeed, Paul takes this further with cosmic design in terms of other life. He writes, "If life is widespread in the universe, it gives us more, not less, reason to believe in cosmic design." Now, for what it's worth, I've never been a great fan of trying to prove the existence of God through the design argument or the Goldilocks enigma. It seems to me that things like anthropic principles and a sense of the intelligibility of the universe and a sense of awe may be pointers to some kind of deeper story, or at least some kind of conversation that we might have, rather than trying to prove God in some kind of logical way. For Davies, it would be a sense that if life had arisen in different places at different times, he would argue in some way that the emergence of life was written into the laws of physics themselves in some way. Now, I think that's an interesting conversation which says, is there something deeper to the universe? But I don't think it is strong evidence for cosmic design. Second, there are those who have argued that encounter with alien life would provide, particularly intelligent life, would provide deep contact problems for religion. This is Jill Cornell Tarter, one of the pioneers of the modern SETI experiments. And she has a view that long-lived extraterrestrials either never had, or have outgrown organised religion. She says that if they arrived, the little green women and little green men, they would have far greater technology than we would ever imagine. And she couples that with greater philosophical understanding, particularly of knowledge of God. And therefore, all of the religions represented here in this room would just be out of date, I'm afraid. Would have to go in the light of these super advanced alien religions. Again, I'm not convinced, I have to say. She doesn't seem to understand that certainly the Abrahamic faiths are based on this fundamental belief that it's not our philosophical sophistication that works out God, but that God has in grace revealed something of himself to us. The infinite revealing to the finite in the way that the finite can understand something of God. So I don't worry too much about contact religion. Third area, and we get into the more wacky fringe, if I might use the technical term, and that is God an alien? And there have been a number of claims of this. J.M. Blumrick, in a book, The Spaceships of Ezekiel, argues that Ezekiel 1 has nothing to do with the Lord encountering human beings, but of spaceships and with astronauts in shiny suits appearing. And these have become very popular, these kind of claims. Some have argued that the New Testament, in fact, is full of aliens, so that the virgin birth was artificial insemination by an alien. The ascension was simply beam me up Scotty, and things of that sort. Now, I don't get this at all. It seems to me that often it's a misreading of the text. but it has very little context to it. So what about the life, death and resurrection of Jesus, the teachings of Jesus, which don't seem to fit with this kind of cosmic conspiracy rewriting of the Bible? Fourth, back to Paul Davies. And that is, however, would there be severe theological difficulties if intelligent life was discovered? And here Paul argues two things. The first is that you Christians, he said, would not be able to understand the unique status, the special status of human beings. Well, I don't buy this at all, because of what I said earlier about Nicholas of Cusa. And that is, I think, the Christian faith says that we are special, not because we're alone, but because of that initiative of grace where God forms intimate relationship with us. And it seems to me that if there were other intelligent life elsewhere in the universe, it's up to God whether he's in relationship with other such intelligent life. It wouldn't undercut our relationship with God. But the second thing that Davis says, I think, is worth taking time to pause and think about a little bit more. And that is, what would be the relevance of the Jesus event to other life elsewhere in the universe? And here Christian theology has had its disagreements. Edward Milne, the great Oxford mathematician, Roman Catholic, believed that it had to be, the death of Jesus had to be once for all. He writes, God's most notable intervention in the actual historical process, according to the Christian outlook, was the incarnation. Was this a unique event, or has it been reenacted on each of a countless number of planets? The Christian would recoil in horror from such a conclusion. We cannot imagine the Son of God suffering vicariously on each of a myriad of planets. The Christian would avoid this conclusion by the definite supposition that our planet is in fact unique. What then of the possible denizens of other planets if the incarnation occurred on only our own? And he concludes, we're in deep waters here in a great sea of mysteries. Well, actually, he goes on from this position to say that if the incarnation and death of Jesus is once for all for the whole universe, then Christians have to become cosmic missionaries. And to be honest, that's a very long missionary journey. It'll cost the church a great deal of money as well. He was opposed by E.L. Maskell in his Bampton lectures in 1956, and Maskell preferred, if there are in some parts or other parts of the universe rational corporeal beings, been a long day, who have sinned and are in need of redemption. For those beings and for their salvation, the Son of God has united, or one day will unite, to his divine person their nature, as he has united it to ours. God becomes little green flesh on another world. And those of you who are from the Christian tradition might remember hymns by people like Sidney Carter, who can tell what other cradle high above the Milky Way still may rock the King of Heaven on another Christmas day. Now, the issue here for Christian theology is really quite interesting, and it poses a number of questions. Christians believe that the incarnation of Christ was for two primary purposes. One was about the revelation of what God is like. Jesus shows us what God is like. The second is about our salvation, our redemption from sin. Now, if you know your C.S. Lewis science fiction, you'll know that Lewis posed the question, might other alien races have fallen in the same way that human beings have fallen into sin? And therefore, do you still need incarnation if there's no sin there? So we've got a number of issues that begin to pile up. We've also got a very interesting issue, which is If there have been multiple incarnations on other worlds, why has there been only one incarnation here on this planet? Might there have been multiple incarnations in different contexts on this planet? Of course, Christianity has long lived with this sense of how the particular relates to the universal. And it's had a long tradition of thinking about how the particular events in the life, death and resurrection of Jesus of Nazareth relates to universal, not least in terms of those people with other faiths. I have to say to you that I have no easy answer to this. I have no PowerPoint slide where I'm going to reveal what I think is the case. I do find some help from Origen, and as one commentator puts, Origen viewed Christ's redemptive work as a transcendent action which gradually through time takes effect in every realm of creation, but which nevertheless needs to find corporeal expression in a particular place on a particular occasion, that is, on Calvary. And I've done a very naughty thing there. I've included a little picture of gravitational waves. I'm not saying that the incarnation works in the same way as gravitational waves do, but you'll remember gravitational waves and the discovery of gravitational waves, how two black holes collided together in a galaxy far, far away, a long time ago. Two black holes, billions of light years away, and they collided, and the ripples in space-time affected every part of the universe. In fact, they affected the Earth by stretching the space in the Earth in one direction by 1,000th of the diameter of a proton. And that's what we measured in the advanced LIGO. Anyway, that's another bit of science. I'm not saying that's absolutely how it happened, but is that a model that might help me to think about how a particular might ripple out to the ends of the universe? So let me move into conclusion, if I may. Thank you for being so patient. I think SETI establishes, as was eloquently said by those who introduced me, a dialogue with theological thinking, a borderlands, as Donald McKinnon would have said, between theology and science. And I'm fascinated by some things. For instance, I'm fascinated by the religious dimensions of SETI. And that is, as I look at some of the writing, either from the scientific community or from the X-Files community, there's a number of themes which begin to spin out. For instance, there's what David Hughes would call cosmic loneliness, a sense of, are we alone in the universe? Spielberg's great thing about E.T., wasn't it? Making it the size of a child so that it could be a friend. What's the purpose of the universe? Might we only discover our identity in relationship to the other, to the discovery of other life? What about this sense of cosmic fear fundamental to science fiction, that life out there is malevolent, it's out to get you, and the fragility of human life in the vastness of the universe? And something about cosmic salvation. Fred Hoyle, many years ago, said that one of the motives for believing in extraterrestrial intelligence was, he said, the need that we have to believe that there's something greater to save us from ourselves. Now, you know where I might go with this next, and that is to say, I think deeply embedded in the Christian faith are some of these themes. That I find a sense of cosmic friendship. I see something of the purpose of the universe. I see in my relationship with God, the other, something of my own identity. Certainly God gives me hope in the face of cosmic fragility, and in Jesus I see salvation. I think then there's something about the challenge of SETI to religion, and that is, in the old words of J.B. Phillips, that the challenge, your God is too small. For often we make God in our image, and we trivialize God. There's something here which is important. I think third, I think theology needs and can contribute to SETI. I think we should be one of the strongest supporters of SETI. I speak as a Christian. Because I think there's something about the nature of extraterrestrial intelligence which we can talk about, just as you rightly said about what it means to be human being the key question of the next decade and beyond. The consequences of future contact, what are the morals and ethics? I do hope that little green women and little green men don't arrive soon. Can you imagine a certain US president greeting? Anyway, that's probably too flippant. I think we encourage, and also there's an ethical dimension, and that is who decides how we use the surface of Mars? Who decides whether we terraform planets which already have some life on them? Who will follow onto terraformed planets? It would be the rich leaving the poor behind on the earth. There's a number of ethical questions. So finally, remember I'm a Methodist, and so I'm under contract to mention the word John Wesley in every lecture that I give. Wesley famously asked about this, replied, "Be not so positive." And so I tentatively put this before you this evening. What I've tried to do is say something about Christianity's contribution. I've tried to do something about the current science, and I've tried to at least pose the questions of what a dialogue might say. And of course, I couldn't leave without coming back to this famous quote from Ernest Walton, Nobel Prize winner: "One way to learn the mind of the Creator is to study his creation." So let's look at the universe and see what's out there. Thank you very much.